So we are ready to learn how to simplify radicals. Now, what on earth does simplify a radical mean? You know, a radical is the symbol that indicates a root, right? This right here is a radical. So here's what it means to simplify a radical. For square roots, it means to write the radical in such a way that no perfect square divides the radical. The radicand. Lots of weird words, right? For square roots, it means to write the radical in such a way that no perfect square divides the radicand. Remember that the number inside under the radical is the radicand, so we don't want any perfect square to divide the radicand. The simplified radical is equivalent, I'm going to write it under here because I don't think I have enough room, but it's equivalent to the original. So we're writing it in a different way that is equivalent to what we started with. This is similar to fractions. Think about fractions. 3/5 is simplified, right? It is simplified because no common factor divides 3 and 5. There's nothing besides 1 that goes into 3 and 5. So that is a simplified fraction. But 10/15 is not simplified because a common factor, and that factor is 5, divides 10 and 15. So since something besides 1 goes into 10 and 15, that will simplify. Sort of kind of the same idea with radicals. The square root of 7 is simplified because no perfect square divides 7. Now, 1 divides 7, but 1 is not helpful, just like 1 is not helpful with going into 3 and 5 and 3/5. So since no perfect square other than 1 divides 7, that's simplified. But 12, the square root of 12 is not simplified because a perfect square, 4, divides 12. Since a perfect square, 4, divides 12, 12 is 4 times 3, that radical is said to be not simplified. So, how do we do it? Well, what you do is we're going to use this property of radicals, that if you have the square root of a product, if you have the square root of two things multiplied together, you can split that up into the product of the square roots. So the square root of A times B is equal to the square root of A times the square root of B. For example, the square root of 100, 100 is 4 times 25. So I can write that as the square root of 4 times the square root of 25. And you can check that and see that it works. You know that the square root of 100 is 10. And you also know that the square root of 4 is 2, and the square root of 25 is 5, and 10 is 2 times 5. So you're going to start splitting up these radicands, the number under the radical, into a product that includes a perfect square. So the square root of 900, if I needed to split that into a product of square roots, that would be the square root of 9 times the square root of 100, right? Because 9 times 100 is 900. So the square root of 64 is the square root of what times the square root of 16? Well, 64 is 4 times 16, so that would be the square root of 4 times the square root of 16. And the square root of 98 is the square root of what times 49? Well, 2 times 49 is 98. So the square root of 98 is the square root of 2 times the square root of 49. Okay, the first thing I want you to do, because this is going to be very important, I want you to list the first 10 perfect squares in these blanks. So there are your first 10 perfect squares. You want to have that list handy so that you can use it to help you with the problems. So when I look at the square root of 12, I'm asking myself, what's the biggest one of these perfect squares that divides 12? Well, 4 divides 12. So I'm going to split the square root of 12 into the square root of 4 times the square root of 3. Notice I wrote the perfect square first, okay? Now, the square root of 4, we know the square root of 4 is 2. The square root of 3 is irrational. I can't simplify it any farther. It is not a perfect square. So the square root of 12 is 2 times the square root of 3. We will usually read that as 2 root 3. Let's do a couple more together. So the square root of 28. Look at your list of perfect squares. What perfect square divides 28? 4 divides 28. 4 times 7 is 28. So I can split the square root of 28 into the square root of 4 times the square root of 7 because 4 times 7 is 28. 4 is a perfect square. The square root of 4 is 2. The square root of 7 is not a perfect square, so it stays under the radical. And the square root of 28 is 2 times the square root of 7. I will normally read that as 2 root 7. What about the square root of 40? What perfect square divides 40? 4 does, right? 4 goes into a lot of things you're going to find. But I can split the square root of 40 into the square root of 4 times the square root of 10. The square root of 4, as we know, is 2. 10 is not a perfect square, so the square root of 10 stays like it is, and I end up with 2 root 10. So the square root of 40 is simplified to 2 root 10. Okay, let's do this one. The square root of 600. Tell me what perfect square divides 600. 100 does, right? This is 100 times 6. So the square root of 600 is the square root of 100 times the square root of 6. Now simplify this and give me the final answer. The square root of 100 is 10. The square root of 6 stays as it is. So the square root of 600 simplifies to 10 times the square root of 6, or 10 root 6. Okay, square root of 45. What perfect square divides 45? 9 divides 45. So I can factor the square root of 45 into the square root of 9 times the square root of 5. Now, finish it up and tell me the simplified form of the square root of 45. The square root of 9 is 3. So I end up with 3 times the square root of 5, or 3 root 5. Well, what if there's already a number in front of the radical? So here's what you do. If I have 2 times the square root of 18, and that is multiplication between there. When there's no symbol written in between, that's multiplied. This is 2 times the square root of 18. So I know that 9 divides 18. So I can write this as 2 times the square root of 9 times the square root of 2, because 9 times 2 is 18. So I still have that 2. That 2 is hanging around, times the square root of 9 is 3. The square root of 2 stays where it is because it's not a perfect square. And now I can multiply this 2 times 3. So I end up with 6 times the square root of 2. So if there's already a number on the outside, you're going to multiply it by whatever square root you get to take out. Okay? So 3 times the square root of 25, 3 times the square root of 75. Tell me, hint, 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 what perfect square divides 75? 25 divides 75. So this is 3 times the square root of 25 times the square root of 3, because 25 times 3 is 75. Now, let's finish this up. This would be 3 times the square root of 25 is 5 times the square root of 3. I can multiply the 3 and 5 because they're both outside the radical, and I end up with 15 times the square root of 3, or 15 root 3. Now, one thing to help yourself so that you don't have to simplify more than once is to always choose the largest perfect square that divides the radicand. And I'm going to give you an example of this. Okay, so the square root of 82, or I'm sorry, the square root of 72. I'm looking at that, I'm going, okay, what goes into 72? And I know 9 does. So I could split this into the square root of 9 times the square root of 8. The square root of 9 is 3. The square root of 8, not a perfect square, and I think I'm done. But notice that 4, which is another perfect square, divides 8. You are not done if a perfect square still divides the radicand. Remember that the definition of simplifying is that no perfect square can divide the radicand. So I need to do this again. I'm going to say 3 times 8 is 4 times 2. So I'm going to split the square root of 8 into the square root of 4 times the square root of 2. So 3 times the square root of 4 is 2. That square root is not a perfect square. Can't do anything with it. Multiply those and I get 6 root 2. So notice that took me a few lines. What if I had looked at 72 though, and I realized that, you know what? 36 divides 72. I can factor the square root of 72 into the square root of 36 times the square root of 2. The square root of 36 is 6, and the square root of 2 remains the square root of 2. Notice I got the same answer, but it only took me one step instead of 1, 2, 3, 4, 5 steps. So the larger the perfect square that you can start with, the better.